Hey guys, welcome to another snow day. We can't fall too far behind because we're doing 2 years in one, kind of two courses that slightly overlap. So we're going to do a little bit of review of Trig and then keep moving on. There'll be a homework assignment at the end of this video that's in your green book. What I'll do is I'll take pictures of those pages and post them on Live Binder in case you don't have the green book at home. Sound good? Okay, here goes. Let's go back. We talked about the unit circle, a circle of radius 1, whose equation is x squared plus y squared equals 1. The last time we met, we dropped a perpendicular from the point where the terminal side hit the unit circle, and that point's coordinates are x comma y. In class, we talked about that the sine of theta would be y over 1. The cosine of theta would be x over 1. And the tangent of theta would be y over x. Solving these out together, we saw then that the sine of theta is equal to the y coordinate on the unit circle. The cosine of theta is equal to the x coordinate on the unit circle. So in other words, wherever we have the terminal side, this point here where the terminal side intersects the unit circle has coordinates of cosine theta, sine theta. We also talked about how the slope of that terminal side, which is the change in y over change of x, is the tangent of theta. Now tangent of theta can also be written as y over x, but y is sine of theta, and then the x is cosine of theta. So that was our new definition of tangent. Now, in the last video that Mr. Ambrose was so nice to make, he defined three new trigonometric functions. These are what we call the reciprocal functions. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. A lot of times people will remember that the cosecant begins with c, but it's the reciprocal of sine, which begins with s. Likewise, secant begins with s, is the reciprocal of cosine, which begins with c. So it's kind of the opposite of what we'd like. With that said, there are some reciprocal identities which are also true. Now, by identity, I mean a statement that whatever you plug in for your variable will always be true. For example, just kind of a quick aside, x plus x equals 2x is true regardless of what you plug in for x. So this leads us to some reciprocal identities. If the reciprocal of sine is cosecant, then what do you think the reciprocal of cosecant is? You guessed it, sine. If the reciprocal of cosine is secant, then the reciprocal of secant is cosine. And lastly, if the reciprocal of tangent is cotangent, the reciprocal of cotangent is tangent. Now, I just want to add here that cotangent, since it's the reciprocal of tangent, can be thought of then as cosine over sine. So tangent, which we did up here, is sine over cosine. Cotangent is cosine over sine. I think of the cotangent having the co on top. That's our first set of identities. The next set are what we call the Pythagorean identities. Remember how x squared plus y squared equals 1 on the unit circle? That's its equation. Well, if you remember correctly, the x is the equivalent of the cosine of the central angle. So we could call it cosine theta squared. The y is equivalent to the sine of theta. So we can think of this as sine of theta squared equals 1. For some reason in trig, instead of writing it as something squared, when we square cosine, we write it as cosine squared plus sine squared. These two statements are equivalent. When you look at formula sheets, they really usually put the sine squared first. So this is our first Pythagorean identity. Regardless of your angle, sine squared plus cosine squared is always equal to 1. Now, you might wonder, is this true even if we're not on a unit circle and the radius is any number? And I'm going to say point blank it is. If you look over here at this triangle, let's kind of plug in what we know and see what happens. If I do the cosine of theta, that's going to be b over c, and I square it, and then I add to it the sine of theta, which is a over c squared. That's going to be the same as b squared over c squared plus a squared over c squared. Well, a squared plus b squared, we know in the right triangle, is always c squared, and c squared over c squared will equal 1. Now, there are, and let me just finish the statement over here. This is our first Pythagorean identity. There are 2 more. These are really easy to find by just doing a little division. So, if we start with this first identity, sine squared plus cosine squared equals 1, and you go back and you divide everything by sine squared, you will get the second identity. Sine squared over sine squared is 1. We know that cosine over sine of an angle is cotangent. So the second term is going to be cotangent squared. And the reciprocal of sine is cosecant. So 1 over sine squared is cosecant squared. So this right here is our second Pythagorean identity. Now again, we can go back to the original identity, sine squared plus cosine squared equals 1, and we can divide everything instead by cosine squared. And now we get sine squared over cosine squared is tan squared. Cosine squared over cosine squared is plus 1. And the reciprocal of cosine is secant, so this will become secant squared of theta. So with that said, here is the third Pythagorean identity. So the first one is sine squared plus cosine squared equals 1. The next one is 1 plus cotangent squared always equals cosecant squared for any angle. And the third one is tan squared plus 1 equals secant squared. If you remember the first one, and that you can divide by either of the functions to get the other 2, it's pretty simple. The other thing that kind of helps me out here is that I think of co-functions. If I put the word co in front of tangent, which is right here, I get cotangent, and if I put the word co in front of secant, I get cosecant. So again, if I can remember the third one, the 1 plus tangent squared equals secant squared, I can pretty much replace the tangent and the secant with cotangent and cosecant squared. Okay, the last identities are the cofunction identities. Thinking about it, maybe I should have done these first. But let's just kind of go with this. If I place the word co in front of sine, I get cosine. If I place the word co in front of tangent, I get cotangent. And if I place the word co in front of secant, I get cosecant. So these pairs, which I've put in the same color, are what we call cofunctions. And there's something kind of nice true about cofunctions. And let's look at the following picture to kind of see what happens. If I do the sine of theta, it's opposite over hypotenuse, which is A over C. Now if I go to the other acute angle in the same right triangle, which is 90 minus theta, and I do cosine, it's also going to be A over C. Notice how these co-functions are equal, that their angles theta and 90 minus theta have to be complementary. Let's go over to tangent theta and cotangent 90 minus theta. Well, tangent is opposite over adjacent, so that's A over B. Now if we go to cotangent 90 minus theta, which is the angle complementary to theta, cotangent isn't opposite over adjacent, it's adjacent over opposite, which is A over C. Likewise, we could do the same with secant theta. Secant is the reciprocal of cosine. So cosine would be B over C, but this will be C over B. If I do cosecant of 90 minus theta, that's the reciprocal of sine. The sine would have been B over C, but its reciprocal is C over B. So cofunctions are equal if their angles are complementary. Remember from geometry, complementary angles that add up to 90. So if I wanted to say tangent of 80 equals, and I wanted to write it as a function of an acute angle, say less than 90, or let's say less than 45, I can think, well, the cofunction is cotangent, and cofunctions are equal if the angles add up to 90. Another typical problem would be secant x equals cosecant x plus 4. Cofunctions are equal if their angles add up to 90. So now I could solve for x and get each angle. One angle would be 43, and the other angle would be, so it would be the secant of 43 degrees would equal the cosecant of, well, what's 43 plus 4? 47 degrees. With that said, I hope you took some notes while you watched this video. This is the homework in the green book. If you don't have the green book, I'm going to take some pictures of the pages and post this on Live Binder right in today's Notes tab. The last thing I want to do is just a quick 1, 2, 3 refresh. Okay, so let's get all the identities down. You should have known the values of sine, cosine, and tangent off the unit circle as the x and y coordinate, x for the cosine and y for the sine of the angle, and the slope is tangent. From Mr. Ambrose's last video, you should have known that the reciprocal functions did exist, and we extended them now with the reciprocal of cosecant being sine, the reciprocal of secant being cosine, and the reciprocal of cotangent being tan. We derived 3 Pythagorean identities. Sine squared plus cosine squared equals 1. 1 plus cotangent squared equals cosecant squared, and tangent squared plus 1 equals cosecant squared. Equals secant squared, excuse me. And the last, cofunctions are equal if their angles add up to 90 degrees. Good luck on the assignment.